So welcome to this segment as we try to look at how to calculate the critical angle in your physics again. So it says the refractive index of a special type of glass is 1.5. So they have given you, in this case, the refractive index. Remember, the refractive index represented by small letter n of a particular special type of glass is 1.5. Then it says calculate the critical angle of this type of glass. So if you have the refractive index, yes, it is possible. You can calculate C, which we call the critical angle for any type of material. So the formula that we apply is sine C. Sine of the critical angle is equal to 1 over n, where n is simply the refractive index. Now the idea is that you want to find C, so you can make subject of the formula by dividing sine, but dividing sine gives us just sine inverse of 1 over the refractive index. So if you want, you can go direct and just use this one. So the critical angle will be sine inverse of 1 over the refractive index, which is 1.5. So when you're typing it on the calculator to extract the sine inverse there, what you do, you press shift or second function if it is there on your calculator, then you press sine, that will give you inverse. Then you can type in 1 over 1.5, and you can actually close it in brackets. So sorry, I was actually doing some additional mathematics questions, so my calculator is in radians. So make sure that your calculator is actually in degrees. So again, shift or second function sine inverse, then 1 over 1.5, and that is simply going to to give you what you want. So angles are left to one decimal place, so therefore if you look at what I have, it will be 41.8 degrees, and that means that is the critical angle for this type of a material. So as long as you know the refractive index, yes, you can calculate the the critical angle by applying this formula here, which we can also say critical angle is equal to sine inverse of 1 over the refractive index. So that's the way you can go about it. Then the second question there was saying state one condition for total internal reflection to occur. So they just wanted one conditions, but we can give you two conditions in most cases. That's what they will be telling you. So one of the condition is that the a ray of light must be moving from a more denser medium to a less denser medium here. Then the other one, what we mean, the angle of incident I should be greater than C than the critical angle. That's another condition that is needed. So we can write and simply say the angle of incidence. So the angle of incidence must be greater. So must be greater than the critical angle. That's what I said. The angle of incidence should be greater than the critical angle. That's one of the condition. The second condition is that the ray must be traveling. So the ray must be traveling from a more denser medium to a less denser medium. So that's what you need to do. Yeah, so from a more denser medium to a less denser medium, that's what we mean. So that's basically for total internal reflection to occur, then these two conditions must actually be satisfied. Now just to help amplify, let me just clean up that so that you are able to see what I mean. I mean, in this case, let's take for example, this is glass and this is air. Air is actually more denser than glass, is more denser than air. So meaning the ray must be traveling from glass going into air. Then if this angle of incidence this angle of incident is greater than the critical angle, then all the light is going to be reflected back into the denser medium. That's what I mean when I talk about these two conditions. So very important that you could talk about. Now, when total internal reflection takes place, like last year's question that they asked you there, it simply means that the angle of incidence I will be equal to the angle of reflection. So as long as as long as total internal reflection takes place, then the angle of incident will always be greater than the angle of reflection. So that is what you need to remember. Now, of course, they are going to tell you to talk about application. Where can we apply application in this case of total internal reflection? So in most cases we apply them in what we are calling as being optic fibers, and optic fibers are simply being used in telecommunication. Optic fibers can be used in telecommunication because they transmit information at a very high speed, no interference that is going to be there. Then you can also use them in medicine. In medicine, optical fibers are simply used as endoscopes. So doctors used to check internal organs, or when they are carrying out operation, they can simply use them as being endoscopes. And in this case, if you have, for example, an optic fiber of this nature, this is a fiber. Let me just use dotted lines to show the end of a fiber. It can be very long. When light enters, it will start bouncing until it comes out of the material. And at the point where it is bouncing there, you are going to see that the angle of incident will always be equal to the angle of reflection. Even here, if you were to draw a normal, or even there, this angle I should be equal to R. At any point, the angle of incident will be equal to the angle of reflection until it comes out from the optic fiber. So that is what you're going to find. So it has a special type of material, that it is made up of, so that this is able to take place. And remember, information is actually going to be transmitted at a very high speed in an optic fiber. Another question, we can also use them in what we call as being a periscope. Application of total internal reflection, we can also use them in what we call as being prism, periscope. So you can also have a glass periscope. It is possible. Yeah, so in case of in a periscope, for example, if they have actually given you something like that, which came in one of the exams there, they'll be telling you, oh, there's maybe a tree that you want to see, because there's an obstacle somewhere here, like a wall that is blocking you. So the eye position should be somewhere down here. Then here you are going to have a prism and another prism, but all these are going to be at an angle 40. They are going to be inserted at an angle 45.